Okay, we're going to take a look at an example of finding a relative extrema with a function that has some inverse trig functions. So we're going to look at arc sine of x and minus 2 arc tan x. Arc sine x has a domain restriction from -1 to 1. Arctan has no problem, so we have to go with arc sine because it's picky. Gotta compromise. Okay, so we've already practiced doing all the different derivative rules here, so we're going to go ahead and take the derivative, and because we're looking for a relative extrema, we want to find those critical points, or critical numbers. Critical numbers are where the original function is defined and where the first derivative is either undefined or is equal to 0. So that's what we're going to look at here. So we're going to take the derivative, and a derivative of arc sine is going to be 1 over 1 minus x squared under the square root. And you might say, hey, well, look at that. It's undefined at plus and minus 1. So that would be something that we look at, but we can't look past minus 1 or 1 because that's outside the domain of arc sine. So 1 is kind of like it's a critical number. It's on the boundary of the function. And then we'll have minus 2 over 1 plus x squared. That has no domain issues. Okay. So what we're going to do is we're going to take that first derivative and we're going to set it equal to 0. Okay. And then what we're going to do here is, now this is all college algebra, all of it. We're going to multiply both sides by this. Okay. That's what we're doing there. Clear that fraction. And then what we're going to have is we have a equation that has a square root in it. And so from college algebra, what you did is you isolated the square root, or if you had 2 of them, you isolated one of them, and then you squared it. So that's what we're going to do. We're going to move that square root business over to the left. And then we're going to square both sides of the equation. So that 2 becomes a 4, and we just distribute 4 and then minus 4x squared, and then we have to FOIL the other side, which will become 1 plus 2x squared plus x to the 4th. Okay? Then from college algebra, you would first hope it factors. It doesn't factor. Then you would try the rational roots theorem, and you would not be able to get anything there. Then you'd have some other methods. But in the interest of time, we're going to go ahead and use Wolfram Alpha. So at this point in time, I plugged this into Wolfram Alpha and asked it to solve it. It gave me 2 complex answers, 2 complex conjugates, and then it also gave me 2 real solutions as my critical numbers. And they were plus and minus 0.618125. Then what I did is I made my little number line, and I tested values in the first derivative. And I'm looking for positive or negative, so I test values in the first derivative. So over here I could have tested maybe negative 7.5. I cannot use negative 1 because it's not in the domain. Then I could have tested maybe like 0 and then 0.75 over here, for instance, in the first derivative, and I'm looking for positive or negative. If it is positive, that means the function is increasing. If it's negative, it means it's decreasing. So I went increasing, decreasing, increasing. So here I would have a max, and then I would have a min at those locations relative. Okay, and I'm going to give you the ordered pair. Okay, how I find the y-coordinate in this ordered pair is I have to take that negative 0.68 blah blah blah. I have to plug it into the original function, not the derivative, the original function. And then I do the same thing for the relative min. I take that 0.6 blah 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 and I plug it into the original function, and that'll tell me my relative min and relative max for that particular function. Okay, so just like what we did in Cal 1, the only thing really new here is the derivative of the arc sine and the arc tan, and then the little bit of college algebra got snuck in there too, which is fine.